So here we have two sets, A and B. A contains the elements 1, 2, and 3. B contains the elements 4, 5, and 6. And we need to find out of the following four relations, R1, R2, R3, and R4. Some of them are going to be relations from A to B, and some of them are not. Okay, let's begin with the first relation, R1. So here we have three ordered pairs, 1, 6, 3, 4, and 5, 2. Now, what is the domain of the relation R1? The domain of R1 is simply going to be the set containing the elements which occurs in the first position of each ordered pair. So here we have 1, 3, and 5. So that means the domain of R1 is going to be 1, 3, and 5. Now, here we see that except for element 1 and 3, 5 is an element which does not belongs to the set A. So now since 5 does not belongs to the set A, this immediately tells us that if we take the Cartesian product of A and B, then 5, 2, that is not going to belong to that Cartesian product A and B, which means that R1, this R1 is not going to be a subset of the Cartesian product of A and B. It's not a subset. And since it's not a subset, so here we can immediately say that R1 is not a relation. This is simply not a relation from A to B. Okay, coming to the second relation, R2. So here it will compute the domain of R2, the relation R2. So what we'll do, we'll consider a set and the elements are going to be the first element of each ordered pair. So here we have 1, 2, and 3. Now as we can see that all the three elements 1, 2, and 3 are also member of the set A. So clearly we can say that R2 is going to be a subset of the Cartesian product of A and B, because if 1, 2, and 3, the domain of R2 belongs to the set A, then we can also see that the range, let's confirm that as well, the range of R2 must belong to the set B. So what will be the range of R2? Those are going to be the second element of each ordered pair. So here we have 5, 6, 4, 6. So 5, 6, 4, 6 means we have 5, 4, and 6. These are the elements which belong to the range of the relation R2, and clearly 5, 4, 6 also belongs to the set B. So clearly R2 is going to be a subset of the Cartesian product of A and B. This simply tells us that R2 is a relation. R2 is a relation from A to B. From A to B. Okay, finally, next we come to R3. So R3 has got the ordered pairs 4, 2, 4, 3, and 5, 1. Clearly, 4, 2, this does not belongs to the Cartesian product of A and B, which implies that we do not have a relation between 4 and 2, the ordered pair 4 and 2. This simply means that R3 is not a subset of the Cartesian product of A and B. So here R3 is going to be not a relation. So here R3 is not a relation. Coming to the final one, R4. R4 is simply the Cartesian product of A and B. We know that when we take the Cartesian product of A and B, and we have a relation R4, we know each and every element of R4 must be a subset of the Cartesian product of A and B if the relationship goes from A to B. Now, since we have a relation for which is itself the Cartesian product of A and B, definitely we can say that R4 is a relation, and it is indeed going to be a relation from A to B.